Welcome to qnawire.
In question 18, we're told that a transparent liquid fills a cylindrical tank and that the height of the tank is 3.6 meters and that there's air above the tank. And you're looking into the tank in normal incidence and you see that there's a pebble at the bottom of the tank. So since the pebble is at the bottom of the tank and the liquid fills the tank all the way to the top, this is actually the height of the tank is also the object distance. So that right away tells us that S is also 3.6 meters. So let's keep that in mind. And we're told that the apparent distance of the pebble when you look into the tank is 2.45 meters. So that's our S primed. And we're asked to find the index of refraction of this particular liquid. And I've actually referred you to example 34.7, where it's sort of a similar situation, except that you're given the indices of refraction and you're asked to find S prime. And the reason why I point you to this example is that they explain there a little bit about the sign convention of S prime. And I'll talk about that a little bit here. So what will happen in this particular case, if you look at that problem, you see that the image forms somewhere, well, clearly from here. Let's use this because we have some numbers to compare. We see that S is 3.6 meters and S prime is less. So the pebble appears higher than it actually is to your eye when you're looking into the water. And so we have that the image is formed on the incoming side of the light. So everything in this tank will be considered the incoming side of the light, and when it exits, that's the outgoing side. And since the image is on the incoming side by the sign convention that they have in section 34.1, that means that S prime is negative. Okay, so that's something important to keep in mind. And if you don't correctly account for this, you will end up with a negative index of refraction. So let's now go ahead and solve the problem if we have some of the bases covered. And we'll use equation 34.13. And that tells us that we have NA over S plus NB over S primed is equal to 0. And our goal is to solve for NA, that is the liquid, and the index of refraction of the liquid that we do not know. However, we have S prime, and we have NB. So it's just a matter of rearranging and solving. So if we do some rearranging of this equation, we can find that NA is equal to minus S over S prime NB. Okay, and now we'll plug in the numbers while keeping in mind that S prime is less than 0. So let's write that explicitly as negative 2.45 meters. Okay, so now NA is equal to minus S we know is 3.6 meters. S prime we know is negative 2.45 meters. And of course, NB, we're told that there's air above the tank, so that's just 1. So times 1. And now notice that we have a positive number here, And the answer that we get is 1.47.